Okay, next, example 3. Okay, so this is a bit different compared to the previous one, where from the previous example, the limit, the integrand, all are given. Okay, just we have a complete double integral, you just evaluate. But for this example 3, they just give you the integrand, but there is information about the region looks like. So in this case, your task is, you need more tasks, which means that you have to decide which order of integration, whether dx dy or dy dx. And also you have to obtain your own limit by using the information provided. Okay, so now the example 3. So what we have so far, the integrand is 2 minus y dA over the region. So this kind of question is very general. So the hardest part here, you have to the first, okay, you have to which one you have to settle down first, where you have whether you have to find out the limit and then after that determine the order, or you have to determine the order first and after that you have to determine the limit. So actually first you have to sketch the region first, because at the moment you have no idea the region looks like. But even though they mention that it is a rectangle, but still we have no idea the limit of x and the limit of y. So it is more easier for us to determine the limit of x and y from the by sketching of the region. So now based on the information provided, we should have a rectangle. So we have a rectangle where the vertices at 0, 0. So this is y and this is x. And also at the point 3, 0. So let's say this is 3. So 3, 0 is here. And then 0, 2. So let's say this is 2. And this is your other vertices. And the other vertices is at 3, 2. So over here. So meaning that what you can see here, you have 4 vertices to cover or to enclose the rectangle. Using that 4 vertices, you have the closed and bounded rectangle, which means that when you sketch that, you have something like this one, right? So from this, you can see that the limit of x is from 0 to 3, and the limit of y is from 0 to 2. So now what you can see here, your double integral now becomes a new form where you have to firstly determine the order of integration first. So as I mentioned before, you have 2 options, whether you can use dy dx, which means that you want to integrate respect to y first, or you want to integrate respect to x first. So it's up to you. So let's say here I want to okay, just look at here, the answer is dy dx. So I just want to have dx dy. So dx dy, which means that you have to integrate respect to x first. So the limit of x is 0 to 3. You can see now, first you have to decide, first you have to sketch the region. So now you know that you have a rectangular region, so all your limit must be constant. That is the first. Second, determine which order of integration that you want to use. So we have decided to use the dx dy, but maybe if you want to use the dy dx, so it's up to you. And after you decided to choose the type of order, then you have to find out the limit. So based on the information provided, so we know that x from 0 to 3 and y from 0 to 2. 0 to 2. And then now you have a complete double integral, so we can start to integrate, which means that you have to solve for the inner integration first. So which means that now you have you have to integrate 2 with respect to x. So you have 2x and then y constant, then integrate yx, which means that y1, so there is 1 here, and 1 becomes x, so you have yx. So the limit So now you are integrating with respect to x, so your limit belongs to x. So x from 0 to 3. So, and then you have to replace the x. So 2, 3 minus y3 minus 0 dy. So when we simplify, you will get 6 minus 3y dy. So now you can see there is no more x, right? Just in terms of y. So now limit of y is from 0 to 2. So then integrate with respect to y. So 6y minus 3y squared over 2. So 6 2 minus 3 over 2, 4 minus 0. So 12 minus 6, and you will get 6. Okay, so that is the step if you use the dx dy. But if you look at from the answer provided in the notes, they use the dy dx. As I mentioned before, you have two options, whether you want to have dy dx or you want to have dx dy. So you can see here, if you use the dy dx, so your step is more shorter. You will obtain a shorter step rather than you use this. But still, both can be solved. I mean, using both order of integration, so they will get the similar answer. Okay, so that is for the example 3. Okay, maybe you might wonder, how can I know that I supposed to use the dy dx or I supposed to use dx dy? So if you have this particular example, so you can do both order of integration. But sometimes if you are given another integrand, sometimes it's quite complicated for you to integrate, for example, respect to x. So you have to, so to make it easier, so you have to integrate respect to y first. Maybe from the next example, I can show you how to determine which order of integration that suit with the given integrand. Or I would say that more easier to be solved by to be integrate with respect to y first or to x first. Okay, so I will show you some example on the next video.